Hi students, today we are going to see a assumption concept 3 sector of a circle, right? Concept 3 sector of a circle. What is the name of the chapter? Areas related to circles, right? In this chapter now we are going to see concept third, right? Sector of a circle. So before solving, right, before solving the sums in this concept, we have to recall the formulas. First we will recall the formulas. What are the formula we are going to use in this concept? First we will recall and then we will solve this, right? Sector of a circle, right? What is mean by sector? The area enclosed between two radius with the arc, right? The area enclosed between two radius with the arc, and this part is called, what is it? Sector. This part is called nothing but sector. Now we are going to find, right? Find the area of sector by using the formula. What is the formula? Area of a sector is equal to theta by 360 into pi r square, right? We know clearly about that formula. The pi r square is nothing but area of a circle. Now we are going to find a part of a circle, right? How much parts depending upon the angle, right? That is nothing but theta. So theta divided by 360. 360 is nothing but a complete angle of a circle is nothing but 360. Among the 360, what angle, right? What angle of area we are going to find? That is nothing but theta divided by 360 into pi r square. So area of sector formula is nothing but theta divided by 360 into pi r square. If theta is less than 180, right? If theta is less than 180, and it will be minor sector. If theta is greater than 180, then it will become as a major sector. If theta is equal to 180, what is? It's a sector, but we can call it as, it's not a sector, we can call it as a semicircle, right? If theta is 180 degree, exactly the angle is 180 degree, then it will become, what is it? Semicircle. By using semicircle formula, what is the formula of finding semicircle? Area of a semicircle, pi r square divided by 2, right? So you want to know that what is meant by sector? Sector is nothing but area enclosed between two radii, right? With the arc, right? The area enclosed between two radii, OA and OB is nothing but radius enclosed with an arc, and this particular area is nothing but sector. Yes, if the theta is less than 180, right, then that is called a minor sector, and if theta is more than 180, it will become major sector, right? For both the same formula only. Finding area of minor sector also the same formula. For finding the area of major sector also the same formula, right? Next, length of an arc. Before that, we want to know what is mean by arc. A part of a circumference of a circle, right? A part of a circumference of a circle. See, this is the circumference of circle, a complete circumference of circle. Among the circumference of circle, and now I am going to find only the length of an arc, that AB alone, right? AB alone, and this is called arc, right? What is it? This is called a arc, a part of a circumference of circle, length of an arc. We are having formula, the same formula. It's a part of a circle. So what is the circumference of circle? 2 pi r, right? 2 pi r. A part of a circle means depending upon the theta, right? If it's depending upon the theta, we can calculate the part of a circumference of circle. There is nothing but theta by 360 into 2 pi r. While we are simplifying 2 and 360, we'll get theta by 180 into pi r. Theta by 180 into pi r. Perimeter of a sector. See, arc means only by calculating this AB alone, right? Only by calculating this AB alone, that is nothing but, what is it? Length of an arc alone, right? Length of an perimeter of a sector. That means which one is called as a perimeter of a sector? See, that entire part, arc plus radius, right? This arc plus radius plus radius. So length of arc plus length of arc, how we will denote? L, right? L plus 2r. L plus 2r. 1 radius plus 1 radius, 2 radius, 2 radius plus L is nothing but, yes, perimeter. Perimeter is nothing but, while we are calculating the, yes, outer layer alone, right? That is nothing but perimeter of a sector. That is nothing but L plus 2r, right? L is nothing but length of an arc, already we know the formula, and 2r is nothing but 2 times of radius. What is L? Theta by 180 into pi r plus 2r. So perimeter of sector is nothing but theta by 180 pi r plus 2r. And just recall that. One more thing. If we know the length of an arc, right? If we know the length of an arc, right? Then we can find the area of sector. Something but area of sector is equal to half into L into R. Right? If you know the length of arc and radius, then directly we can find the area of sector. That is something but half into L into R. Right? And this is very important formula because we can expect this kind of questions from 1 mark, right? They'll give directly the value of L and R radius, right? And ask you to find the area of sector, right? For finding the area of sector, see, for finding the area of sector as well as length of arc or perimeter of sector, what are things are we are needed for finding the area of sector, otherwise length of arc or perimeter of a sector, whatever it may be, what are things we are needed to find these things? Only two things. One is something but theta, another one is something but radius. Here also, what are things we are needed? Theta and radius. Here also, theta and radius, right? Theta and radius. If you know the value of theta and radius, then directly we can find the area of sector or perimeter of sector, whatever they are asking, sir, right? Suppose if they are giving the value of area of sector, then we have to equate this formula with that value, right? They will ask you to find whether theta or radius, right? They will ask you to find whether angle of a sector or radius of a sector, right? So by equating, right? Not only the area of a sector, if they are giving the value of length of an arc, right, there is a chance to ask you to find theta or radius. Directly, this is a formula. Equate with the value of length of arc. By simplifying, we'll get the theta or radius, right? So we are needed two things. One is something but theta and another one is something but radius, right? Theta of a sector, right? Theta of a sector. And moreover, you have to keep only one thing in your mind. There is nothing but minor sector and major sector. Same formula, minor sector and major sector. Depending upon the theta, we are considering that it's minor or major. Minor sector or major sector. Suppose they will give only the angle. The theta is equal to 45 degree and they ask you to find the major sector, area of major sector. How we will find? First we want to find the angle for the major sector. How we want to find the angle for the major sector? Yeah, it's very simple. They are giving the minor sector angle, right? 360 minus 360 minus minor sector angle. Angle of minor sector is equal to angle of major sector. Angle of major sector. Right? So this is enough today, right? Just recall this formula, and I told you that the formulas are very, very important. Please thorough the formula. Right? And if you know the formulas, by reading the question, what are things we are having in the question, right? What are things we are having in the question? Just start out the given from the question, and if you know the formula, write the formula and substitute and simplify, you will get the answer. So please thorough the formulas first, right? And today this class is over, and tomorrow we will see the sums based on the sectors of a circle, right? Thank you.